Hello, and welcome to Dreamology, a quiet place for curious minds, a space where nothing needs to be solved and nothing needs to be rushed. If you are here right now, it means your body is ready to slow down, even if your thoughts are still moving. So let your shoulders soften, let your breathing become longer, let the noise of the day dissolve, as if it were drifting away from you in the distance. Tonight, we are not searching for answers. We are not collecting information. We are simply floating through galaxies. Not just our own Milky Way, but some of the most fascinating galaxies in the entire universe. From silent dwarf galaxies, to enormous spirals, to shattered remnants still glowing from ancient collisions. We will drift through invisible halos of dark matter. We will pass black holes flickering like distant candles. We will touch new galaxies glowing softly at the very edge of the known universe. Some of these ideas may feel unreal.
Others may feel strangely familiar, like memories you do not remember having. But every single thing you hear is real. Every one is a quiet echo from the vast and ongoing story of the universe. A quasar is a galaxy whose black hole outshines all its stars. At the center of some galaxies, black holes grow slowly hungry. They do not rush, they do not explode, they simply pull. Clouds of gas and dust begin to spiral inward. As they fall, the material heats up. It glows, it releases energy. When the black hole consumes matter at a high rate, the galaxy becomes what we call a quasar, a single point of light, brighter than billions of stars combined. Some quasars are visible from billions of light years away. Their light has been traveling across the universe since long before Earth existed. The light does not come from inside the black hole itself. It comes from the disk of material around it, matter moving in near-perfect circles.
Heated to millions of degrees, releasing enormous energy as it falls inward. For a brief moment in cosmic time, the entire galaxy becomes one of the brightest objects that will ever exist. And then, slowly, the feeding ends, the light fades, and the galaxy returns to silence. There are also galaxies that contain almost no light at all. No stars, no clusters, no glowing gas. Yet they exist. These are dark galaxies, made almost entirely of dark matter, the invisible substance that outweighs visible matter across the universe. We do not find them by looking for light. We find them by watching how they bend space, by how they distort the light of distant objects behind them, by how they gently tug on neighboring galaxies. Some were discovered only through gravitational lensing, others through subtle patterns of motion in nearby gas. No one knows exactly how they formed. They may be failed galaxies, or the quiet remnants of galaxies long erased.
They drift through space like silent shadows, hidden islands of gravity, perfectly real, almost completely unseen. Even now, the universe is filled with structures we cannot touch, cannot see, but which quietly hold everything together. And somewhere among them, our own galaxy continues its slow journey. Right now, the Milky Way is in the middle of a slow and quiet transformation. Our galaxy is gently absorbing a smaller companion, the Sagittarius dwarf spheroidal galaxy. It is not a violent collision. It is not a dramatic event. It is gravity, working patiently over millions of years.
The Sagittarius galaxy has already passed through the Milky Way several times. Each passage stretches it thinner. Each passage pulls more stars away. Long streams of these stars now wrap around our galaxy, like delicate ribbons drifting through space, faint traces of a galaxy being slowly digested. The Sagittarius dwarf is not gone yet, but it is fading.
Pulled apart by forces it cannot resist. Its remains help astronomers understand how the Milky Way grew. Not all at once, not in a single moment, but through the gradual accretion of smaller galaxies. What we see in the night sky today is the result of countless events like this. Quiet mergers, slow transformations, endless reshaping. Our galaxy is surrounded by invisible stellar streams, remnants of other galaxies that were absorbed long ago. These streams loop and spiral around the Milky Way's halo. They are made of ancient stars that once belonged to entirely different systems. Some are still relatively intact. Others have become diffuse and faint, their original shapes lost to time. Mapping these streams allows astronomers to reconstruct the past, like finding fingerprints left behind by cosmic encounters. The sky above us appears calm and unchanging, but in reality, it is filled with motion. Every star is moving. Every galaxy is drifting.
Even now, we are passing through the echoes of events that happened billions of years ago. Our home is not a fixed place. It is a slow river of matter and light, flowing through deep time. The Milky Way is also being gently stretched by the gravity of nearby galaxies, especially by Andromeda, our nearest large neighbor. These forces are called tidal forces. They act slowly, like the pull of the moon on Earth's oceans, but on a cosmic scale. Over millions of years, they create subtle waves in the outer regions of our galaxy, ripples in the spiral arms, soft distortions in the disk. Stars shift their paths, gas clouds drift. Nothing remains perfectly still. Even something as vast as our galaxy is shaped by forces larger than itself. A reminder that no structure in the universe exists alone. Everything is connected. Everything is in motion. The Milky Way feels enormous when we think about it. Hundreds of billions of stars.
A disk more than 100,000 light-years wide. A structure so large that light needs thousands of centuries just to cross it. But compared to the true giants of the universe, our galaxy is only average. Some galaxies are more than 100 times larger than the Milky Way. The largest known galaxies are giant elliptical systems, like IC 1101, which stretches for several million light-years from end to end. These galaxies sit at the centers of massive galaxy clusters. They did not become large by forming stars alone. Over billions of years, they swallowed dozens, sometimes hundreds, of smaller galaxies. Each merger added more stars, more gas, more mass. Their cores are dense and ancient, filled mostly with old red stars. Their outer regions fade slowly into darkness, where lonely stars orbit in vast, slow circles. They are quiet structures, stable, massive, so large that even our entire local group would fit comfortably inside them.
Some galaxies form stars at an extreme rate. The Milky Way produces perhaps 1 or 2 new stars each year, a slow and steady rhythm. But some galaxies experience periods known as starbursts. In these systems, hundreds or even thousands of new stars are born every year. Dense clouds of gas collapse under gravity. Shock waves pass through interstellar space. Energy floods the galactic core. These outbursts are often triggered by interactions, 2 galaxies passing close to each other, or slowly merging, or colliding head-on. The result is a sudden blaze of activity, ultraviolet radiation, hot dust, glowing gas, newborn stars lighting up the galaxy from within. But starburst phases do not last long. The gas is consumed quickly, the fuel runs out, and the galaxy gradually returns to a quieter state. For a brief moment, however, these galaxies are among the brightest objects in the universe. At the heart of nearly every large galaxy
lies a supermassive black hole. Ours is called Sagittarius A star. It sits quietly at the center of the Milky Way, about 4 million times more massive than the Sun. But the black hole at the center of the Andromeda galaxy is even larger, at least twice the mass of ours, possibly much more. Right now, both black holes are relatively calm. They are not actively feeding. They are not shining as quasars. But in the past, they may have blazed. And in the future, when the Milky Way and Andromeda merge, their black holes will begin to spiral toward each other. Over millions of years, they will orbit, lose energy, draw closer. Eventually, they will merge into a single, even more massive black hole. 2 galaxies, 2 centers, 1 future heart. We can also look back in time simply by looking far away. Light from distant galaxies has been traveling for billions of years to reach us. Some of the faintest galaxies we can see
appear as tiny red smudges in deep space images. They are not seen as they are today, but as they were when the universe was young, only a few 100 million years after the Big Bang. Small, chaotic, filled with dust and rapidly forming stars. These early galaxies ended the cosmic dark ages. They shaped the large-scale structure of the universe. They became the building blocks for all galaxies that exist today, including our own. Their light has crossed more than 13 billion years of space, and somehow it still reaches us. Not all galaxies are made mostly of stars. Some galaxies are made almost entirely of gas. Cold clouds of hydrogen drift through space, with very few stars to light them up. These systems are known as dark gas galaxies. They are nearly invisible in optical night. No bright cores, no glowing arms, no clusters of stars. We only detect them through faint radio signals emitted by hydrogen atoms.
They may be galaxies that never formed stars, or remnants of collisions, or systems where star formation was shut down before it truly began. They have mass, they have structure, they have motion. But without stars, they remain hidden, floating quietly between brighter systems. Invisible potential, waiting in darkness. Some galaxies reveal themselves not through light, but through gravity. When a massive galaxy lies between us and a more distant object, its gravity bends space itself. The light passing behind it curves, it stretches into arcs, sometimes into perfect circles. This effect is called gravitational lensing.
It allows us to see galaxies that would otherwise remain unseen, too faint, too dusty, too distant. These lensing galaxies act like natural telescopes, magnifying the deep universe behind them. By measuring how strongly the light bends, astronomers can calculate the galaxy's mass,
including the invisible mass of dark matter. In this way, we can weigh galaxies without ever touching them. Even the unseen parts leave fingerprints in the bending of light. At the centers of many galaxies, supermassive black holes produce enormous jets. When these black holes feed, they pull in gas and dust. The material swirls in disks. Magnetic fields twist and tighten. Twin beams of energy are launched outward at nearly the speed of light. These jets can stretch for millions of light years, far beyond the galaxy itself. In radio images, they appear as glowing threads piercing intergalactic space. They heat surrounding gas. They shape galaxy clusters. They influence star formation across vast distances. Some of the largest known structures in the universe are created by these jets, and all of them begin from something smaller than our solar system, a single point, where matter meets gravity and releases light into the dark.
The oldest known galaxy formed just a few 100 million years after the Big Bang. The early universe was quiet, dark, almost empty. Then gas began to cool. Matter began to gather. The first stars ignited. The oldest galaxy we have detected so far appeared only about 300 million years after the beginning of time. Its light has been traveling for more than 13 billion years. It is small, filled with young stars, surprisingly organized for something so ancient. Observing it allows astronomers to study the universe in its infancy, when galaxies were first learning how to exist. We cannot see it clearly yet. It is faint, redshifted, distant. But with every new telescope, we look a little deeper, and the galaxies we find carry the earliest chapters of everything that followed. Some galaxies are built almost entirely from stars that once belonged to other galaxies. When galaxies collide or pass close to each other,
Gravity can tear stars away from their original homes. Long tidal tails form. Arcs of light stretch across space. Stars drift into new orbits. Over time, some of these stolen stars gather together and form entirely new systems. These are called tidal dwarf galaxies. They do not begin as most galaxies do. They are not formed from pristine gas clouds in the early universe. They are built from debris, from borrowed matter, from fragments of past collisions. They often contain very little dark matter. They may not survive for billions of years, but for a while they exist as real galaxies, shining with second-hand light, holding together through newly formed gravity. They are reminders that even destruction in the universe can quietly create something new. Some galaxies rotate in the wrong direction. Most galaxies spin in the same direction as the gas from which they formed. As clouds of matter collapse, they begin to rotate.
That rotation sets the rhythm for the entire galaxy. But some galaxies break this pattern. Their stars rotate one way, while their gas rotates the opposite way. These are called counter-rotating galaxies. The most common cause is a merger. A galaxy absorbs another one, and the incoming material carries its own momentum. Instead of blending perfectly, the two motions remain separate. Sometimes only the central region rotates backward, sometimes the entire disk does. These systems are rare, quiet, frozen records of unexpected encounters. They carry the memory of ancient collisions written directly into their motion. A single galaxy can host thousands of globular star clusters. Globular clusters are dense, spherical groups of stars. Each one contains hundreds of thousands of stars packed into a region only a few light years across. They are among the oldest objects in the universe. The Milky Way has around
150 globular clusters. But some giant elliptical galaxies have thousands of them. They form vast swarms extending far beyond the visible edges of the galaxy. Each cluster is a fossil, a preserved piece of early cosmic history. Some formed during the birth of the galaxy. Others were captured from galaxies that were absorbed long ago. By studying these clusters, astronomers learn how galaxies formed, how they merged, how they evolved. They are memory keepers, small, ancient companions carrying stories billions of years old, orbiting quietly in the dark outer halos of galaxies. Even in silence, they continue to move. The Milky Way may feel still, but our galaxy is constantly moving. Relative to the cosmic microwave background, the Milky Way is traveling through space at nearly 600 kilometers per second. That motion includes many layers: the orbit of our Sun around the galactic center,
The slow drift of the Milky Way toward Andromeda, and the movement of our entire local group toward a massive region of gravity, known as the Great Attractor. We do not feel this motion because everything around us is moving together. But astronomers can measure it through tiny shifts in background radiation, through the velocities of distant galaxies, through the way light itself changes as space expands. Space is not a fixed stage, it is dynamic, and we are part of its flow. The Milky Way is not alone in the universe. It belongs to a small collection of galaxies called the local group. This group contains more than 50 galaxies spread across roughly 10 million light-years. The two dominant members are the Milky Way and the Andromeda Galaxy. A third, smaller spiral, known as Triangulum, also plays a significant role. Most of the remaining galaxies are dwarfs, small, faint systems containing only a few million stars.
Some orbit the larger galaxies like satellites. Others drift more freely through the outer regions of the group. Over billions of years, these galaxies interact. They pull on each other. They exchange stars. They merge. The local group itself is part of an even larger structure, a vast supercluster known as Laniakea. This supercluster contains hundreds of thousands of galaxies spread across hundreds of millions of light-years. All of them are moving together, drawn by gravity toward massive concentrations of matter. Around every large galaxy, including our own, there exists an invisible halo. This halo is made of dark matter. It does not emit light. It does not absorb light. It does not reflect light. Yet it outweighs visible matter by more than 5 to 1. Astronomers discovered these halos by studying how galaxies rotate. Stars at the edges of galaxies move far faster than expected. They should fly away. The only explanation is the presence of unseen mass holding everything together. Without dark matter halos,
Galaxies would not survive. They would slowly drift apart. Instead, they formed inside these halos, shaped by them, guided by gravity we still do not fully understand. Dark matter halos extend far beyond the visible edges of galaxies. They overlap, they interact, they form the scaffolding of the cosmic web. The universe is held together by things we cannot see. And yet, their influence is everywhere. Every orbit, every cluster, every filament of galaxies follows their quiet pull. Even now, as you rest, your galaxy is moving through this invisible structure. Galaxy clusters are among the largest gravitational structures in the universe. They can contain hundreds or even thousands of galaxies, all bound together by gravity. When astronomers measured the visible matter in these clusters, the stars, the gas, the dust,
It was not nearly enough to hold them together. The galaxies should have flown apart. Something else was providing the missing gravity. That something is dark matter. Dark matter makes up most of the mass in galaxy clusters. It holds the galaxies in place. It slows their motion. It keeps the cluster stable over billions of years. We cannot see it directly, but we detect it through the way galaxies move, through the way light bends as it passes through clusters, for the temperature of the hot gas between galaxies. Without dark matter, clusters would dissolve. Instead, they remain intact, islands of light floating in a dark ocean. Clusters themselves gather into even larger structures called superclusters. These are the largest known formations in the universe, regions stretching hundreds of millions of light years, containing thousands of galaxies. They are not solid objects, but loose networks of systems, slowly drifting together through space. Our own galaxy belongs to one of these superclusters, called Laniakea. The name means immeasurable heaven. Laniakea contains more than 100,000 galaxies, all moving within the same vast gravitational basin. On the largest scales, galaxies are not scattered randomly. They follow an invisible structure known as the cosmic web. This web is made of dark matter and gas, forming long filaments across the universe. Galaxies form where these filaments intersect. They move along them. They grow where matter is most concentrated. Between the filaments lie enormous voids, regions almost completely empty, spanning tens or hundreds of millions of light years. Most of the universe is actually made of these voids, vast silent regions with only a few lonely galaxies drifting inside. The web itself was shaped by tiny fluctuations in the early universe, amplified by gravity over billions of years.
We have mapped parts of it. Simulations reveal the rest. But most of the structure remains hidden, defined by dark matter we still cannot directly observe. And within this immense network, our own galaxy continues its journey. In about 4 billion years, the Milky Way and Andromeda will merge into a single galaxy. Not suddenly, not violently. Slowly, gracefully, over hundreds of millions of years. Their stars will mostly avoid direct collisions, but their shapes will distort. Their gas clouds will interact. New stars will form. Astronomers sometimes call this future galaxy Milkomeda. Our solar system will likely survive the merger, carried into a different region of space. The process has already begun. Andromeda is moving toward us at more than 100 kilometers per second.
We simply live on a timescale too short to feel it. Nothing in the universe is truly permanent, but nothing is ever completely lost. Galaxies are born.
They grow, they merge, they fade. Matter rearranges itself endlessly, changing form but never disappearing. And somewhere within this vast motion, within this endless transformation, we find ourselves. A small world, orbiting an ordinary star, inside an average galaxy, drifting through an invisible web. The universe continues whether we watch it or not. Galaxies keep moving. Black holes keep feeding. Light keeps traveling across time. But for now, you do not need to follow it. For now, you can rest. Let your thoughts slow. Let your breathing soften. Let the night carry you. This was Dreamology. And wherever you are, may your dreams tonight be wide, quiet, and full of gentle light.